Dark Secrets of the Sun, Solar System. Dark Secrets of the Solar System. New evidence is rewriting the history of our solar system, and using the latest discoveries and cutting-edge tech, experts are investigating. If our cosmic neighborhood once featured oversized alien Earths and a second sun for most of history, humanity did not recognize or understand the concept of the solar system. Most people up to the late Middle Ages Renaissance believed Earth to be stationary at the center of the universe and categorically different from the divine or ethereal objects that move through the sky. Although the Greek philosopher Aristarchus of Samos had speculated on a heliocentric reordering of the cosmos, Nicolaus Copernicus was the first to develop a mathematically predictive heliocentric system. The solar system, A, is the gravitationally bound planetary system of the Sun and the objects that orbit it, either directly or indirectly. Of the objects that orbit the Sun directly, the largest are the 8 planets, with the remainder being smaller objects, such as the 5 dwarf planets and small solar system bodies. Of the objects that orbit the Sun indirectly, the moons, 2 are larger than the smallest planet, Mercury. The solar system formed 4.6 billion years ago from the gravitational collapse of a giant interstellar molecular cloud. The vast majority of the system's mass is in the Sun, with the majority of the remaining mass contained in Jupiter. The 4 smaller inner planets, Mercury, Venus, Earth and Mars, are terrestrial planets, being primarily composed of rock and metal. The 4 outer planets are giant planets, being substantially more massive than the terrestrials. The 2 largest, Jupiter and Saturn, are gas giants, being composed mainly of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are ice giants, being composed mostly of substances with relatively high melting points compared with hydrogen and helium, called volatiles, such as water, ammonia and methane. All 8 planets have almost circular orbits that lie within a nearly flat disk called the ecliptic. When the Sun goes dark, there is one part of it that shines brighter than everything else, the corona. The outer atmosphere of our star has literally shed light on many mysteries and continues to hide many more in plain sight. While traveling to some of the most distant and remote places in the world to observe the corona during a total solar eclipse, a research team led by Shadia Habal of the University of Hawaii found that something was off. The temperature from regions where solar wind originates does not change throughout a solar cycle, even though temperatures of magnetized plasma that create structures within the corona can be erratic. Benjamin Bowe, a researcher on Habal's team whose co-authored a study recently published in astrophysical journal Letters, found several unexpected things in 14 years' worth of high-res solar eclipse images. The most surprising thing to me is the number of fine-scale structures that we have been able to see in the corona, Bowe tells Sci-Fi Wire. These hint that much of the corona is not closed, but actually open magnetic field lines which extend into space. Our work points to missing components and incorrect assumptions in the models that need to be addressed. Most previous models assumed that the majority of field lines around the Sun are closed. Because the Sun is essentially a gigantic orb of plasma floating in space, it behaves like any other gas. Because different parts of it rotate out of sync, its magnetic field becomes warped, and some regions are twisted enough to belch out solar storms. Solar wind is propelled through space by phenomena such as flares and coronal mass ejections. It can seriously mess with the power grid on Earth, screw up satellites, and be a hazard to astronauts on the ISS. The researchers figured out the temperature of areas that give rise to solar wind when they studied 2 types of iron ions that commonly occur in the corona. They saw that more relatively cool particles, if you can call anything on the Sun cool, made up the solar wind, and that these were almost unchanging during an 11-year solar cycle. They tend to zoom around at speeds from about 185 to 435 miles per second. Hotter particles still sneak into the solar wind, but are rarer and less predictable. Bowe believes the evidence means that whatever heats the corona and solar wind doesn't really care much about cycles, since it appears to do whatever it wants. The fact that we found essentially the same ion was always dominant implies that the heating of the solar wind is somewhat insensitive to the solar cycle, he says. However, there are other structures like prominences and active regions that do vary with the solar cycle and can release very high-temperature plasma into the solar wind. Sometimes, these structures will throw off the solar wind, but not much of it. Solar prominences, or filaments, start at the surface of the Sun and stretch far into the corona, sometimes blazing hundreds of thousands of miles away. Active regions are seen as sunspots. These are areas where our star's temperamental magnetic field is disrupted, setting off high-energy storms that are part of the reason why Mars, thought to have once been a potential hotbed of life, is a corpse of a planet. A total eclipse of the sun will occur about every year and a half. Sometimes even coronagraphs cannot make out how far the entire corona reaches into space, which is why Hubble's team has depended on eclipses and observed them everywhere from Oregon to Mongolia to the Arctic. Visibility is usually clearest in areas without huge amounts of light pollution getting in the way. There is still no existing technology that gives scientists as accurate a view of the corona as an eclipse, during which the team imaged the sun in white light and studied ions by looking into specific wavelengths. It is not totally clear why the heating process is behaving in such a consistent way, Bo says. Our goal is to provide robust observational context and constraints for future modeling efforts to use, which will then get at addressing the heating mechanisms. The next total solar eclipse will happen on December 4th of this year, but you won't be able to see it anywhere around here. If you want to understand the flamboyant family of objects that make up our solar system, from puny, sputtering comets to tremendous, ringed planets, you could start by immersing yourself in the technical terms that fill the scientific literature. Oblateness, Grobens, magnetosphere, volatiles. By all means, take the plunge if you are so inclined. But if your goal is to develop a more intuitive feel for your place within this colorful community around the sun, you can start the speed course with a single word taken from the world of art, chiaroscuro. Renaissance artists coined the term to describe a novel aesthetic defined by extreme contrasts between the bright and dim parts of a painting. Chiaroscuro, light-dark, in Italian, gave the canvas an expansive, three-dimensional feel and a sense of emotional mystery. To the artists who embraced it, including Leonardo, Rembrandt, and Vermeer, this fresh approach also established a sharp break from the hard, flat style of medieval art. To skywatchers, though, chiaroscuro was just an extremely belated recognition of a natural truth that their predecessors had discovered millennia earlier. The workings of the heavens are expressed through the contrasting interplay of light and dark. The most gorgeous eclipses in the solar system are never visible from Earth. Although light might seem to be the dominant element in the sky, darkness often contains the most powerful lessons. Darkness defined the most awesome and most feared of astrological events, a total eclipse of the sun, and inspired some of the greatest advances in the history of science. Chinese astrologers began producing written records of eclipses going back to at least 2000 BC. By the 6th century BC, the Babylonians had developed a sophisticated calendar that allowed them to predict eclipses with remarkable accuracy. In modern times, solar eclipses led to the discovery of the element helium and violent eruptions on the sun. In 1919, the shadow of a solar eclipse enabled researchers for the first time to validate Albert Einstein's general theory of relativity. Even today, chiaroscuro remains a powerful tool of discovery and comprehension. All across the solar system, darkness exposes the secret locations that light only obscures. The remarkable places where moons are ripped apart, comets are born, and alien life may be swimming about in an ice-cloaked ocean. Like, comment, share and subscribe to my channel.